Good morning, dear participants. We will start after 10-15 minutes. Good morning. Thank you. A very good morning to all the participants. Good morning and welcome to CIPET CSTS-GUWAHATI. We are going to start our inauguration program shortly. Since offline and online, both the participants are there. So we are waiting for 10 minutes more. Thank you. Good morning, everyone. শুনা পাইছেনে?
Ready?
Am I audible?
Short term training from to organized by CPET.
Organized হেল্ল', বিশাল তুমি আহি পাইছা নেকি? তুমি গেট পাইছা নেকি? এক ছেকেণ্ড।
Itu tak terus ya? Ya tes itu.
Good morning, everyone. We are going to start the inauguration program.
Am I audible?
आइए
का विषय है तो बताओ।
तो ये इनपुट स्पीकर्स है, ये ऑब्जेक्टिव से और ये पार्टिसिपेंट ऑनलाइन
ऑनलाइन है। ठीक है, चलिए चलिए चालू करता हूं ना।
Good morning, everyone. Respected Director and Head, CIPET CSTS-GUWAHATI, Dr. Hore Krishna Deka, Head of Training, Dr. Jutika Devi, Assistant Professor, dear participants on online and offline mode, we welcome you to this short-term training program session, inauguration session. This program will last for 1 week till 21st of February. So now I would like to request the Director and Head of CIPET CSTS-GUWAHATI, Shri Sanjay Kumar Chaudhary sir, to deliver his welcome speech. Sir.
Thank you, Ratikanji. As we know, CIPET CSTS-GUWAHATI is organizing this fifth AICT sponsored short-term training program on plastic product manufacturing and recycling techniques from 15th February to 21st February. And I believe from last 4 short-term courses training program, we have trained through the online around the 1200 candidates in the different topics. And this is the, in this financial year, this is the last program, which is another one. Second last, it is a online and offline mode. Due to, between this duration, there is a COVID-19 and Omicron and all this thing. So this is the first program and also getting the special permission to organize that offline mode as well as the online. So I welcome you, all the participants, those who are online as well as offline present in the CIPET CS-GUWAHATI campus. I believe in this program, you will learn a plastic product manufacturing techniques as well as the recycling. Recycling of plastic technique. Right now, in current scenario, it is the most important and developed area where the new things are going on. Between this session, you will meet our experts. A. Rajesh, Joint Director and Head CIPET CSTS Kochi. Praveen Bachao, Joint Director and Head CIPET CSTS Ranchi. SK Jain, Manager Technical Services CIPET CSTS Bhopal, as well as Naved from Assistant Technical Officer CIPET Chandrapur. Amit Alexander, Naipar Guwahati. Amir Mukhtar, Assistant Technical Officer CIPET Guwahati as Gwalior. So I believe there is the objective. What is the objective of this program? Upgrade the knowledge of faculty, researchers and students in the recent technology of emerging area, enable them to learn techniques that can help for a active and successful participant in knowledge for the society as well as industry. So thank you very much, Dr. Ratikant sir and Dr. Deka, and congratulate to organize the type of seminar or short-term course in CIPET Guwahati. Those who are benefited the student from the principal.
East Bengal Eastern University, and then different other organizations all over the India.
Okay. So, thank you very much.
Thank you, sir. Thank you for your valuable speech. Now I request Dr. Hore Krishna Deka, sir. So we'll have an before we march forward towards in detail about this about CIPET, we'll give you a presentation. Before that, I wish to request Dr. Nobendu Dev, Assistant Professor RIST, to give a little speech about the program. Please, sir. Please, Aye.
ब्रांच के हैं
Good morning, all. Friends, present online. This is one of the programs organized by CIPET. We are thankful to Central Institute of Petrochemical Technology for organizing the training program. And this training program is related to the manufacturing of the plastic product and the recycling of the product, which is very much essential. In these days, we are facing a huge problems related to the plastic, and ultimately that leads to serious problems in the climate. So for this, at least we have to start. Let's say we have to think how we can eliminate those plastic sources and the plastic waste, and how we can improve the plastic-related materials. I mean the usage of the plastic-related material, and how it can be essential to the benefits of the society. And for this, we have to start off with the training program. The way that has been conducted by AIT. I hope this program will be good to you all, and at least this will be the stepping stone for you to think of something else in the future. So with this, we wrap up. And, thank you, sir. So we hope already we have explained what you are going to get from this session. This is the topic is plastic product manufacturing and recycling techniques. It's the in polymer sector. I am going to explain about the CIPET, Central Institute of Petrochemicals Engineering and Technology. In short, it is CIPET. It's a Government of India institute functioning under Ministry of Chemicals and Fertilizers, Department of Chemicals and Petrochemicals. This organization, in order to promote this polymer sector industries across the country, this educational institute is an unique institute in India where you will get an industry environment in our learning process. So it was established in the year 1968 in Chennai. I'm going to give a fair picture of CIPET. These are objectives of CIPET to provide qualified professionals at various skill levels through academic, long-term, short-term skill development and entrepreneurship development program in area of petrochemical, including plastics. In CIPET, we offer technology support and consultancy services in areas of design, tooling, CAD/CAM, plastic processing, testing and quality assurance, inspection services, and calibration to petrochemical industries, including plastic industries. CIPET undertakes research and application development in petrochemical sector, including plastic, synthetic rubber, technical textile, solvent fertilizers, petrochemicals, additives, explosives, adhesives, and coatings. To enhance the professional skill and competency level of faculty by providing an opportunity for faculty to upgrade their qualification and technical expertise through advanced training program. And this is similar type of program. We want to spread the knowledge to the student fraternity, to the teaching fraternity so that the people at large are benefited by the different facilities available at CIPET, and in future they can become a resourceful person in the polymer sector for development of our country. This is about this is the picture of our CIPET head office. It is in Chennai. It was established in the year 1968. So at the initial stage, the Central Institute of Petrochemicals, it was the name of Central Institute of Plastics Engineering and Tools. Then subsequently, it became Central Institute of Plastics Engineering and Technology. Now it has become, because of the role played by CIPET for development of human resource and providing technical services in the field of polymer sector, government has enlarged the activity to petrochemical sector. Now, Central Institute of Plastics Engineering has become Central Institute of Petrochemicals Engineering and Technology. So now CIPET is known as Central Institute of Petrochemicals Engineering and Technology, which was established in 1968 with support from UNDP by Government of India. We have around national presence in around 42 locations. Already around 37 locations we have completed, 5 are in the pipeline. So this is a national presence. We have almost in every state of the country, we have our national presence. In northeastern region also, we have our presence in Assam, Manipur, and Tripura. So depending on the educational services, what we are providing from level 1 to level 4. Now, what is that level 1, level 4? You might be knowing. Now is in the skill category. The education system has been divided in level wise. So level 1 to 4 comes under skill category. That is some short duration training programs. It is a sponsored training programs. And from 5 to 7, it is diploma, post-diploma programs, and 8, 9 UG and PG, and up to 10. So in this category, we have our institute like Institute of Petrochemical Technology. Based on the services provided by CIPET, the education, degree and diploma, all these services. So CIPET has been actually categorized in some institute. So the institute IPT is the Institute for Higher Learning, where we offer UG and PG programs, and we have our PhD programs also. We have 3 centers in Chennai, Bhubaneswar, and Bengaluru. That is especially for research programs. UG and PG programs are level 8 to 9. These are the BTech in plastic engineering, BTech in manufacturing, MTech in polymer nanotechnology. So ME integrated MSc. All these are the programs run under this UG and PG, where it is conducted in the Institute of Petrochemical Technology centers. So right now we have such 8 centers. It is in Ahmedabad, Bhubaneswar, Chennai, Kochi, Lucknow, Raipur, Murthal, and Jaipur. Then comes our postgraduate diploma, post-diploma, and diploma programs, which comes under level 5 to 7. So where we offer 3 years diploma, 2 years post-diploma, postgraduate diploma courses. These diploma courses it's meant for the matriculated students. After completing the 10th level, they can join our diploma programs. And after completing the diploma, they can go for post-diploma. And for the science graduate, we are offering a postgraduate diploma in plastic processing and testing. And level 1 to 4, already I told, that is skill. These are the courses of short duration, like 1 month, 2 months, 3 months, up to 6 months. So these are the technical support services. Actually, what we have given to some of the industries. Apart from our educational services, we are providing services, technology support services to the plastic industries in the field of design and tooling, mold manufacturing, plastic processing. So we have those technological services, then testing and quality control, and pre and post delivery of plastic products. So like this, in last 5 years, we have some data from 2016-17. We have completed 66,034 assignments. 70,000 in 17-18, it is 70,056. 18-19, it is 71,056. 19-20, 63,100. And for 2020-21, it is 42,762. As all of us we know that because the COVID pandemic, this has gone down because of the COVID pandemic situation, lockdown and all. So in latter part of 2019-20, the COVID has started. We know from March onwards, lockdown started in the country. So our technical support services were for some time. It was actually we could not provide, but essential service production, everything was going on. This making of seal, etc., some COVID related product, it was made as an essential service in CIPET. CIPET has contributed in this category. So these are the technological support services in short. What we have already explained, that we have different design and different field. Design starting from design and development of molds, then the tooling, then the plastic processing, and then testing and quality control. So these are some of the assignments we have completed. So this is about CIPET CSTS-GUWAHATI, this center. This center comes under CIPET CSTS category. CSTS means Center for Skilling and Technical Support Services, where we conduct courses starting from level 1 to level 7. Short duration courses, say up to 6 months. Beyond that, diploma, post-diploma program up to level 7. So from level 1 to level 7 is conducted in this CSTS category centers. CIPET has categorized these centers. So right now we have around 24 CSTS centers across the country. And in Northeastern region, we have 3 centers. It is 4. We have some special one. There's an unique kind of institute is also there. This is a system concern of the CIPET Guwahati, that is Plastic Waste Management Center. That is the first plastic waste management center established by Government of India in 2008, which has started operating from 2010 within this 5-kilometer radius of this center. So these are the courses we told in CIPET Guwahati. We are offering diploma, 2 diploma courses after having qualification of 10th, that is 3 years diploma in semester system. Then for the science graduate, we are offering 2 years diploma programs. Normally, this admission system and all these candidates are selected through joint entrance examination conducted by CIPET every year. This time also CIPET has notified for entrance examination, and it is available in CIPET website. So CIPET has its own website, that is www.cipet.gov.in. Anyone, if you want to visit, you can visit our website for more details. It has already started, so you can spread the message to your known person, friends and relatives. So these are some of the short-term courses. It is like operator level courses, 6-month courses, operator level, then assistant operator 3 months courses. These are the data what we have trained in vocational training. And this is in skill category, the services what we are providing in skill category, that is recognized by Government of Assam. We have begged the best training provider training center category award in 2018 from Government of Assam, and this is a picture of the awarding ceremony that was given by the then Chief Minister of Assam, Sri Sarvananda Sonowalji. So this is the recognition of our quality services in the field of skilling and training. So these are some of our recruiting partners. You know, CIPET offers campus placement. We have a dedicated placement cell across the country. In almost every center, we have placement cell, and we are well associated to all the petrochemical polymer industries of the country. And some of the industries who are regularly hiring our students from the final year, like Havells India, Marico, Skipper Limited, Tata Autocom, Time Technoplus, Sark Industries, like these are the very renowned industries across the country. So here recently in Assam also we have witnessed many developments in the plastic sector. In Assam also we have our institute that reputed industries like Vectus, they are establishing industries here. Supreme has their already, they have another one factory was there. Now again new plant they are setting up. So Skipper we have Nilkamal. So very reputed industries, Manjusri groups, all are operating in northeastern region and which are giving employment opportunity and entrepreneurship opportunity to the youth of this northeastern region. This is very unique kind. You may be knowing. I hope you have heard about India skill competition. So skill competition. There is a like world football competition is there. We know. World cricket competition we know. So like this in skill category also there is a competition, world skill competition. So that competition is held every 2 years, and this is our students are participating and we are promoting this type of competition in our campus. We have the competency, we have technical expertise in this field, and these are some students they have qualified in the national level from this institute. We are feeling proud with them. They have first they have taken part in state level, first district level, then state, regional level, then national level. So after completing those levels, they have qualified for the national level, and this time it will be held in Shanghai. So these are our some of the facilities, classroom facilities. We have our inside this campus. You might have seen already. We have our boys hostel, girls hostel, these classrooms, and we have workshops, and we are offering extracurricular activities to the students. These are some of the glimpses. These are boys hostel, girls hostel, and this is the hall where we are sitting. Video conferences facility we are having for conducting classes by reputed faculties across the country and abroad well, and we are offering placement services also through video conferencing. So this type of facility we have. We have facility of digital library and conventional library. So this is our CAD/CAM facility where we have softwares like AutoCAD, SolidWorks, EasyNX, CATIA, Solid Edge, ProE. All these facilities we have. We have around 150 workstations, 3 laboratories. You can see. We'll show you later on. This is a tool room department which is equipped with advanced CNC technologies. We have CNC machines, conventional machines, lathe, milling. All these machines are there where molds are developed by our students, and we also offer these technological support services to the industries. This is plastic testing department. This is a very important department. Everywhere we know in quality control, so testing is very much important. So we sorry, this is processing department. So this is the processing machineries where our topic depends. Today we are discussing plastic product manufacturing. You know, for making this different types of plastic product, we use different types of technologies. Some of the technologies like blow molding, injection molding. So these are some of the machine like stress blow molding, extrusion blow molding, now monolayer blown film, pipe extrusion, rotational molding, compression molding. So we have different types of machines and technologies here. These are some of the products it has been developed. This has been manufactured in our processing workshop. This is the mold, some of the molds designed by our tool room departments. This is the processing, some of the design developed by, product developed by our processing department. And testing, regarding testing and quality controls. CIPET has national NABL accredited laboratory and BIS accredited laboratory for conducting different plastic testing as per BIS and NABL accreditation. So these are the glimpses of some training as well as technical services in the testing department. We have association with very government departments for providing technological support services. We have been associated with these departments of government of Assam like Industries and Commerce, Public and Works Department, Directorate of Horticulture and Soil Conservation, Borough Territorial Council. We have association with industries, different industries and institute like CSIR, NEIST, Godrej Consumer Product Private Limited, Supreme Industries, Associates, TCPL Packaging, Jyoti Laboratories, Mukun Pipes, government sector, PhD, Brahmaputra Board, Water Resource, IIT Guwahati. So these are, and BIS, we are providing, we are doing technological support services for these organizations. So thank you very much. So I hope you have got some idea about CIPET. This is the unique institute in polymer sector. Whenever you need something, you can approach us across the country. You may search any CIPET centers in the state. If you are from Assam, here we are there. But if you go to the outside of Assam, you can go, you can see our CIPET centers and you can search us in our website. So thank you very much. With this, I conclude this presentation on CIPET, and I replace Dr. Jutika Devi to go ahead with further programs. Thank you very much.
Thank you very much. Respected Director and Head Sir, CIPET CSTS-GUWAHATI, Dr. Harikrishna Dekasar, HOD Training Department, CIPET CSTS-GUWAHATI, Rutikanta Dasar, PTC Coordinator of CIPET CSTS-GUWAHATI, Abendu Dev from Greece, my dear participants from all over the India, who are, some of you are present here in the offline mode, and many of you are present in the online mode. So this short-term training program sponsored by AICT and on the emerging area, actually AICT provide the programs for the emerging areas where potential of development is more. So this theme of this short-term training program is plastic product manufacturing and recycling techniques. And within this 15 to 21st February, different recent development and on the technologies focus will be there, and from different CIPET centers, director will deliver their expert lecture. Then from NIPAR also, and some of our in-house faculties also will deliver the lecture. I hope all of you will be much more benefited for this. And before going to the tea prep, we will have a photo session. And after that, we will go for the
tea break. Okay. So photo session we will have here only.
Can go outside.
We can go outside also. Banner is also there. If you want to.
So we will proceed for the photo session. Before that, I would like to thank you, Director and Head Sir, CIPET CSTS-GUWAHATI, Dr. Harikrishna Dekasar, HOD Training Department, Rotigantra Das Sir, PTC Department for this organization of this program, and We are here. Paul and me will always be with you here for these 7 days. So if you have anything to discuss or anything to share regarding your stay for the whole day, then you can please come to us, and we are here for you. So we are looking forward, and now we'll go for the photo session. So you please wait here. We will do the arrangement and we will call you. Please.
Mute for next. তাতে করো।
Dear participants, our inauguration session is over, and now we will meet with the second lecture, expert lecture. The lecture will be delivered by Dr. Hare Krishna Deka of CIPET CSTS Guwahati. Please be in the same line, or you can rejoin again within 5 minutes. The link will be sent, so please be in the same line. Thank you. A very good noon to all of my dear participants. Now we are starting our technical session. And in this technical session, I, Dr. Jutika Devi, going to start to share some ideas regarding how the polymer materials can be used for application in different area. We have different application area, just like we can use in wireless communication, we can use in biomedical sector, just say agriculture is there, then different sectors are there. In different sectors, we can use the polymer materials. So since we are focusing on the emerging areas, so we have the, I think all of you have some ideas related to nanotechnology and nanomaterial. So सब लोगों को, you know this, that we have different type of materials and particles. Microparticles, then macroparticles, then suppose if we speak about the chair, table, all these are macroparticles, bigger. Then we have the microparticles. Microparticles is whose dimension is of the order of 10 to the power minus 6 meter. Then we have nanoparticles. Nanoparticles means 10 to the power minus 9 meter. So what is the main difference between the microparticles? Microparticles govern the electronic industry. But day by day, what we have found that there is a very famous law. The name of the law is Moore's law. Many those who are from electrical, electronics, and from computer background, you have the idea that what is Moore's law. Because now what happened? Our number of components in a particular device is increasing. Because with the same device, we are getting more higher features than with compact size. We are not changing the dimension, means including more number of components does not mean that we are making the device much more bigger. Suppose we have an IC. Suppose in our mobile also, if we see our mobile, what we have found in the mobile, we have different features. In earlier mobile, if we see the first mobile, which is by Motorola company, in that mobile, what we have found that the antenna is at the outside. Antenna is at the outside, and what we can do, we can only make call and phone is there, and date and time, all this normal minimum feature is there. But if you say today, if you think of your mobile, what we have found? We have found that there are so much number, as it's just like a small computer. No? We can use PowerPoint, we can use Word, we can do PDF, we can do everything. Then we can communicate via email, then we can do shopping, means almost all the necessary things we can do using our mobile. And cost is also not high. Earlier, if you think or if you googled about the cost of the earlier mobile, which where technology is the, if you see the today's mobile, what you will find that technology has changes drastically. We have touch screen, no? We have touch screen. Earlier, the keypad is there, like that. We have to write the message. No, now you touch the, and before, after 2-3 years, again, what we will find that the artificial intelligence will govern the technological field. Now also in different countries, what we have found that different robots are there. No, robots do welcome in almost all the malls. Robot do household works, everything. So in India also, after 5 years, maybe such type of situation will come. No, robot will welcome us in our malls or in different. So technology is changing. So technology is changing. So with technology, what will happen? The material what we have used for different devices must also be make some advance. Just like simple example, we have cups, no? Cup, the tea cups at our home. Earlier, what happened? Either steel cup or the bonsai cup. Nowadays, we have different cup using the composite materials, no? By which we got. Even some cups are there. Many of you know, and many of you may have bought that also. That there are different cups are there. In that cup, if you fill the cup, then there is a LED. It will light will blink. So that type of cups are also there. That means cost is not so much, but technology is enriching. And how the technology is enriching? The advancement of technology is basically governed by the material. And now suppose here what happened? The lots of things are going on. In CIPET, suppose if you go through, you will get the different kind of polymer type materials are manufactured. Then suppose we have bigger size particles, then smaller is there. Then suppose someone is want to make a thin film of polymer, then testing and characterizations, all these features are there. So what we can do, we can make the material engineered one. We can engineer the material just like the nano material also. In nano, what happened? What is the difference between nano and micro? Since in case of nano material, the size does matter. What it means? Our order is 10 to the power minus 9 meter. Suppose we have a nanoparticle which is having 5 nanometer, and suppose gold nanoparticle. Suppose gold, we all know, no? Everyone have the idea of gold and silver. So that gold nanoparticles, what we are wearing the gold, that is in macro size, no? But it's bigger. And what are the, suppose we have pellet, that pellets are for pellets are of micro size. And when we make nanomaterials, that 5 nanometer gold nanoparticle or 50 nanometer gold nanoparticle, that will have vast difference in their properties. Suppose we have nanoparticles, gold nanoparticles we have, and what we are doing, we are synthesizing it in such a way that 5 nanometer is there, 10 nanometer is there, 50 nanometer is, they will give us different colors it can give. So that means what happened? In earlier LEDs, light emitting diodes, to get different colors, but we have to make functionalize the material by using different components. But in this case, what happened? In this metallic nanoparticles, we are getting different colors for the same material. The difference is what? That we are making its sizes different. That means one particle can serve the different purposes. Now, how it is related with polymer? So we have the knowledge of polymer. What are the polymer materials? Just like if you say plastic materials, if you say rubber, nylon, these are also plastic materials. Then we have organic compounds, inorganic compounds are there. So polyvinyl alcohol, polyethylene, or these are also what? These are also polymer materials. So all of you have the idea, no? In the chemistry classes, in your higher secondary or in your engineering, then what you have got different idea of the organic and inorganic compounds. In case of basically we use the organic compounds, so different polymeric materials are there, and what we do, we take, depending on our applications, we take different polymer material. Now the question is, how this nano material can be made composite with the polymer. Composites means what? Suppose we have one material and we have another material. Suppose one polymer material is there. Suppose another, suppose inorganic material is there. We want to make them, functionalized. That means in case of advanced nanomaterials, what happen? all the materials are man-made, we can say. We prepare it in laboratory. Many of you have experience also, I think, in your, if you have done any project work related to suppose nanomaterial or anything, you may have some ideas. Or if in your organization, some definitely labs are there, no? So in that labs also, what actually the chemical methods we use. Basically, in most of the cases, we use the chemical method to fabricate the nanoparticles. Why? Because it is easy and it is not very expensive. So if the for very sophisticated synthesis process, we use different techniques. But normally just like we can use the microwave oven also to synthesize a material, we can use the microwave oven also. Just like normally what we do in microwave oven, we do heating of different food materials. Then suppose you have to boil a potato, you can keep it inside the microwave oven like that. And what we can do in microwave oven, we can process the material also. So that processing is known as microwave processing. Just like chemical method I have said, then microwave processing is there. Then in some different laboratories in our, suppose in USA and Europe, Israel, all these places, or Japan, we can say, then Singapore, in all those places where so much research is going on in the material point of view, there they use different technologies also. And in our northeast also, if you go through, suppose in your USTM also, or in Nehu also, in Guwahati University, Tezpur University also, there are different laboratories where chemical method is there. Then suppose for electrospinning is there, then we can use different processes. And suppose we want to make a thin film. What is thin film? Suppose this is the mobile. In this mobile, what happened? This is the macro size, no? So this is not a thin film. So here, suppose in this mobile, if we want to put a different material, suppose a polymer material, we can embed it. Then what we do spin coat. We can spin coat it, or if we have liquid, what we can do, we can make it drop by drop. So we can put drop by drop, or we can do spin coating. So we can keep it, and after suppose 10 hours like that, we can found that thin film. If we need more precise type of thin film, then what we do, many of us have used also, and many of you may have seen vacuum coating unit. We can use the vacuum coating unit also to make the thin film. Matlab, we can make thin film of different materials. Then we can say, in that point, we can say this as a substrate. So suppose this one is substrate. Substrate means, suppose I am putting here my laptop, no? This table is there. So table is the base. In that way, when we design a product, we need a base. Okay, that base we say substrate. So that substrate, depending on our application, just like in, suppose if our device, what we are making, this laptop, we can say in centimeter, no? So definitely the base we need is of higher size. So we are putting here, to keep the mobile, we need a smaller or compact base in comparison to that, but still it is in centimeter. So like that, when we are changing the sizes, suppose if our object is of meter size, then we will use more bigger. Then in that way, if we have the millimeter size, then we are using a little smaller. If we have, suppose, micrometer size, then again we will make it more compact. And if we have, suppose, nanometer, then again our substrate will be changed accordingly. So this is known as scaling down. All of we have heard the word, no? Scale down, scale down. So in case of technology also, we scale down. So how we scale down? Depending on our device technology, we scale down. So, and the substrate, definitely to get optimized result. What is optimized? Optimized means in computer simulation or in computer software, we normally use the word optimization. Optimize means for given input, we should get accurate and more precise output. Processing is there inside. So for that, what we have to give? We have to give our design parameter accordingly. So suppose we have already available some products are there. For already available products, what happened? We have the definite size and shape is given. But for some new kind of design, what we have to do? We have to do the calculation. That's why when we go for a product design, then suppose here also, if you go through, you will get that different laboratories are there. There is one laboratory which is known as CAD laboratory, means computer aided design laboratory. Okay, so there different softwares are there. In that software, different devices, like suppose plastic based products, then even different other things can also be, just like some are, suppose like NCC is there, NX is there, KDI is there, like the different one lab is there, where suppose one can do the simulation. And why we do simulation? We do simulation to get the optimized design, because all the things are not so cheap. The products what you are using for designing, there some components are very costly, so we cannot manufacture a product with trial and error method. Suppose we need mud, then we can use so many times. Suppose some product we are going to use manufacture using, suppose, paper, then what will we have lots of paper and it is not so costly. Now so we can use it how much we need accordingly. But suppose we are using suppose gold nanoparticle, if we are using suppose silver nanoparticle, if we are using graphene, like that different costly material if we use. Suppose what I have said about the substrate, your substrate may be less costly, but the thin film what you are going to make is suppose more costly, then we cannot use it in trial and error method. So we cannot go for the experiment first. So what we can do? We can do first the simulation. As many of you know it also, and many of you go through that also. No, when we run a program, first what we do? We execute. No, then after that, if it is working, then we can go for the hardware. Suppose like for hardware purpose, or we can connect with the hardware to get the device. So another important point is, whatever we manufacture, whatever product we design, all has a particular goal. And other important point is what a market is required. Suppose if you go through different, a very few days ago, and now also it is at news, no, outside Bajaj industry has got that, and one is that Mahindra has picked up some Jugaad type ideas. So I think you knew it. No? In news, it is coming very much. So that technology is so different. So what we do, whatever product we design, we always look for a market. Just like in market also, some devices are there. Just like the diabetic patients go to test their sugar level. No, when they go to check their sugar level, that device is definitely not so costly. No, if for suppose one test, if it costs suppose like 500, then a normal common people cannot afford for that. So it takes hardly 40 rupees, 20 rupees, like that. No, people go to check their diabetes. I think all of you have seen this, no? In nearby medishops and nearby pharmacy, everywhere almost this glucometer is available here. So that is what? That is also a technology. But that technology is what? That technology is label free. Just like when we go to our laboratories to diagnose or test then what happened? Then there is a particular level. That means for a definite chemical parameters, a scale is there, no? So on that scale, it is fixed that above this, if the result we found above this, then it will be what? The people will be diabetic or like that. Or but here that such type of no level is there. Here that percentage is showing, and then the result will come and people will get that yes, my sugar level is higher or my sugar level is at the range or it is lower. So that is technology, and technology always go for the market. So in this, suppose this polymer nanoparticles, those are what? Those are also not so older technology or older components. So people are using different nanomaterials, and people are doing just like what I have earlier said, no, that people are trying for different materials. So if material is less costly, then people can go for direct experiment. And suppose if it is more costly, then what will people do? People first go through all the details, then do the simulation, go for the basic theory, and if everything works, then people will go for the experiment. So every case is what happened. The global market plays an important role. Now what is the impact? So nanotechnology is a rapidly growing technology, and it has potential application in many sectors and different key men. And even if you Google that, you will get that in all over the world, different government agencies are funding. In India also, we have different government agencies, and in these different government agencies, what happens? Suppose like we have Department of Science and Technology, like this. AICT is also a government agency who give us funding. Then Department of Biotechnology is there. So these are some government agencies, and in these government agencies, all are having particularly a cell which is for nano mission for DST. We have in that way in all over the world. Suppose USA, in USA also has a definition. So all are what? All are sponsoring the research work or the practical works related to the nanomaterials. And these are the key manufacturers. Even what happened, many of us are familiar with, and many of you, if you Google, you will get that there are different companies. What they sold? They sold the nanoparticle. They sold the nanoparticles, and what that nanoparticles are? That nanoparticles are of different sizes. And suppose different we need suppose we need the scattering properties. Scattering is related to light. That means if we needed optical properties, then the particles we are using, that will be of higher size. Suppose same gold nanoparticle we are using, suppose, and suppose we need an absorber, then we will go for the smaller size particle. Means suppose 10 nanometer, 15 nanometer nanoparticle we are using. That nanoparticles will, their properties are dominated by the absorb. So they can be used for as absorber, or and that those have also, just like in radar technology, then defense, all those things that is used. Suppose we need the application of the same gold nanoparticle in uh, medical technology, then what will happen? We will go for some bigger size particles. So depending on the application, what we will do, we will have different sizes of the particles. So these are some of the applications, just like agriculture and food, defense and security, energy storage, materials, optical communications, electronics, biomedical, biotechnology, cosmetics also. In sunscreen lotion also, nanomaterials are used. And suppose if you go through advertisement, we all get, no, the in suppose TV screen, no, new, when the many TVs are giving the advertisement, where what we have found in that that nanotechnology is incorporated, just like just like invisible properties are there, no? Just like this is used in, suppose in Bin Laden case also, that in that what invisibly it is targeting, no? There also nanomaterials are used, and different in depends in different sectors, just like what I have seen. Suppose imaging also, suppose we want to take photos, then also there are different types of nanomaterials which are used. Then suppose like digital clock, CLOAK, clock, there is a word clock. So yes, that for that also nanomaterial. And even for I think even for sensing, no, that can also be used. So this is the flow, how which sectors took the revolution, how the revolutions come. From 1800 to 1853, textile has lead the market. That is the revolutionized area at that time. Then 1853 to 1913, railway is there. Then 1913 to 1969, automobile is there. Just like in 1969 to 2025, computer is there. Then 2005 to 2061, distributed intelligence is there. Then from 2025 to 2081, it is predicted that nanotechnology have suppose a material, that material have a non-zero permeability, then that we say as magnetic material. Just like iron, if we speaks about iron, manganese, those materials are what? Nickel also, those materials are magnetic materials. And in iron also, suppose ferrous oxide is there, that is also what? Fe3O4 or Fe2O3, like that compound, those are magnetic materials. So for magnetic purposes we use that. And if we speaks about permittivity, that is what? That is associated with your electric field. And when we this actually this dielectric property is related with the refractive index also, isn't it? So, and we know velocity of light, that also we can obtain, no, using epsilon naught and mu naught. There is an expression by which we can relate that the permittivity and permeability, and we can get the velocity of light. I see, no? Okay, so already I have explained. Now I will just show you the diagrams. So what I have said, that till 150 years, people are thinking that there are only three passive elements: resistor, capacitor, and inductor. So resistor, we all know V equal RI from Ohm's law. Capacitor also we know it is related with charge and voltage, and inductor also we know it is related with the flux, no, and current. And after 150 years, in 1971, Leonoshua has postulated that no, there is another passive element. And what is that passive element? That is memory store. Okay. Resistor, capacitor, inductor, and another one is memory store. Memory store means what? Memory resistor. That means the resistance what we are discussing, that one is static one. But what this one is? This one is dynamic one. That means what? With time and space, this resistance varies. Means normally suppose R equal 1 ohm. That R equal 1 ohm is what? Static. R equal 1 ohm means R equal 1 ohm. It has nothing to do with the position. It has nothing to do with the time. But in case of memory store, what happened? Their behavior or their values differ with the space and with the time. So now I have just now said about the permittivity, no? So how this resistor, capacitor, and inductor, normally everyone have seen it also, no? Resistor, capacitor, suppose copper का एक coil हम लोगों ने क्या करती हूँ, there is coils, no? If we do number of turns, it can work as an inductor. Capacitor, resistor, color code resistance, all of you have done those experiments also. So those things we can use from outside lamp. But when we are using nanomaterials, a nanomaterial or a nanoparticle can also behave like a resistor, capacitor, and inductor. But how we will know which nanomaterial has the behavior of resistance, which nanomaterial will show the behavior of capacitance, which nanomaterial will show the behavior of the inductance. So here when we are using a material where, and all of we know that in complex permittivity there are two parts, no? One is real part and another one is imaginary part. And those who do not know, just means the in permittivity or in dielectric profile, there are two parts. One is real part and another one is imaginary part. And in real part, what information they give to us about the energy storing, no? And in the imaginary part, dissipation, how much loss is there. So in that way, here, if we are considering a nanoparticle, suppose, if that nanoparticle's real part is greater than 0, so that is also important. If we take some inorganic nanomaterial, suppose we are taking cadmium sulfide, very simple and very easy to synthesize. So if we take cadmium sulfide, then what we found that its real part is greater than 0. But if we take gold or silver nanoparticle, its real part is smaller than 0. Metamaterial. There is a concept of metamaterial. And metamaterial is what? Negative refractive index. So if the real part is less than 0, that means suppose gold or silver, then it can work as an inductor. And suppose we have materials which are whose real part is greater than 0, that they will behave as a capacitor. And those material whose imaginary part is not equal 0. Gold has also the imaginary part not equal to 0. Cadmium sulfide has also, or if you say zinc sulfide, zinc oxide, iron, nanoparticles, different nanoparticles are there. So different materials are there. So for all those, suppose some may use manganese also, and graphene also is there, carbon nanotube is also there. So if we use, depending on their permittivity profile, we can use it as an inductor, as a capacitor, and as a resistor. So suppose we want a device where R and C we require, then what we can do? If we need R and C, then what we can do? We can make the structure, use it in that way. Suppose we need an LC, that means we need two different nanomaterials where one having real part greater than 0 and one having real part less than 0. So this is a structure. And another important point is that not always, not only spherical, we may have different structure. Suppose we may have triangular, rectangular, like the different and one important point is there are different types of nanomaterial: single component, double component, even 3-layer, 4-layer structures also we can do. And those where different layers are there or different structures are there, that one is known as heterostructures. So this is a core cell nanostructure. So in this core cell nanostructure, this one is core cell. That means 2 layer is there. One is core and one is cell. So here only nanoparticle will not be there. We need a medium. Just like before some times ago I have said, no, suppose we are in this classroom. Suppose if we say this conference room is a classroom, then this is a medium. A medium is there where we are here. In that way, these nanoparticles are also, or nanostructures also, are in a medium. Since we are focusing on polymer, this one is polyvinyl alcohol. So this polyvinyl alcohol is the matrix, the medium where we are putting the nanoparticles. So I am just going to give the basic concepts. So here, suppose these are the core cell particles, and it is not necessary and it will not be that only one nanoparticle is there. Suppose we have a bottle of nano solution. In that nano solution, what will happen? 100 nanoparticles may also be there. In that 100 nanoparticles are there, definitely they are in a medium. So here I have just written air, but in this air is suppose replaced by polyvinyl alcohol. Some may replace it by water, some may replace it by any other medium. Okay. So in a particular medium, what will happen? These core cell particles are here. Now, different structures are there. It's like if we say single component means there are one component. Suppose gold is there, then gold nanoparticle may be in spherical shape, maybe in rectangular shape, maybe it is in pellet, like that condition. So in that way, there will be single component. If we speak double component, then what will happen? Two components are there. And if we say effective, and this is a medium, no? This is the host matrix, and here these core cell particles are there. So this is a medium. This is an effective medium. That means all together will work. Whatever properties we are getting, that properties we are getting for that whole structure, whole system, we can say. Not for the not for a particular medium. So we can make different applications of different materials for it. Suppose we can use metal core, we can use metal cell. If we say metal core, metal cell, suppose we can use gold and gold, suppose silver and silver, gold and silver, like that. Metal core dielectric cell. Metal core is suppose gold. Let us take the example. And dielectric cell, we can take suppose iron oxide also, we can take aluminium oxide, we can take silica, like that. And metal core and polymer cell. Metal core, suppose gold and silver we are using, and polymer cell, suppose we are using we can use different types of material. Suppose Teflon also sometimes is used. When we want to make some micro size, then we use Teflon also. Teflon, I think you have heard about, no? Teflon container is there, on Teflon bowls are there, like that. So semiconductor core and semiconductor cell. This semiconductor core means what? There are a lot more semiconductor material. So you know, no? Different types of semiconductor core is there and different semiconductor cell is there. That means we can use different semiconductor material as the core of the structure and different semiconductor material as the cell of the structure. Then what we can use? We can use polymer core and polymer cell. We can use two different polymer materials. Then dielectric core and dielectric cell. Suppose someone is using zinc oxide as core, or suppose zinc sulfide or cadmium sulfide as the cell. Then polymer core and dielectric cell. Polymer core we can use, suppose any kind of polyethylene, suppose we are using, or any kind of polymer matrix we are using. Then dielectric cell means we can coat it with the help of the dielectric cell. So it has different applications, just like in organic light emitting diodes, organic photovoltaics, and suppose solar cell. No, you have the idea of solar cell. So in solar cell also what happened? Nanomaterials are used. Then for sensors, already I have said, and in sensor lot more works are going on in our Northeast India also. So Northeastern region, if you go through and if you go through the website of IIT Guwahati also, you will found that different, just like kits are also developed, no? Different kits are also developed in the COVID time also. Different kits are developed using them. Then in Center for Soft and Nano Research in India, what they have used the nanomaterial in the masks. I think in news it has come, no? In news also 3 layers masks are available where nano is incorporated. So actually what they do just like silk, lot more work is going on related to the silk also. So with nanomaterials, silk material, which we have, no, silk. So silk material is the artificially engineered, and it is also used in the health sector. So for biomedical, if we say this material have application in health sector, how it is applied in biomedical? Suppose we have bioimaging. Bioimaging means what? Suppose we have the scanning technology, no, CT scan, computer tomography. That is also imaging. You have the idea of the CT scan. Now, what in CT scan? The MRI. So what actually in CT scan it is the photograph of the internal tissues, veins also, it also comes, no? How your tissue is there, and even there are one is normal CT scan and another one is dye injected CT scan. That means some materials are, some colors are injected from outside, and when it is injected from outside, then the resolution of the image will be more. So in that technology also, this nano materials we can use. And drug delivery, you know, no, in cancer, in the treatment of cancer, targeted drug delivery is there. And this technology is not new. Ascorben, there is a technology where for the cancers that affected tissues are treated, giving the drugs in targeted ways, so that healthy tissues which we have do not get much affected. And these nanoparticles have also application in drug delivery. Then biosensing, already I have said. So in biosensing, what we can do, we can make some assembly. Just like I have said, no, in this bottle of, suppose if we consider this bottle, the solution in the bottle as nanomaterial, then what will happen? We can say it is an assembly of nanoparticles, because here there may be 10 nanoparticles or like that, and all those, they are what? They will have some mechanism. Since nanoparticle will have different behavior, what will happen? There will be a zone, conducting zone and non-conducting zone. Conduction we all know, no? So there will be some, just like in p-n junction diode, what happened? We have some interface, no? Some region, depletion region, and in case of FET also we know, MOSFET also, then detecting cancer cell. So we will not go very depth to this, but a basic idea. So what I have said, these core cell nanoparticles can be used for drug delivery, bioimaging. So very briefly and shortly, how it is. Suppose what I have said, this is an effective medium. In this effective medium, this is scatterer. Already I have said, no, when we go to radio, suppose in radio frequency we are there. So in radio frequency, we speaks about voltage and current. No, suppose we are connecting, we give voltage and we get the output as current. But when we are going to the microwave region, what happens? We get it in terms of transmission coefficient and reflection coefficient. Means depending on the frequency band, the parameters output we get, just like when we have fever, if we measure it using thermometer, then what we get the temperature. So in the same way, when we have suppose used at 1 kilohertz, suppose we are giving voltage, then suppose we can get current. In microwave domain, what happened? Electromagnetic signal or electromagnetic wave, that like before few minutes ago I have said, no, microwave oven can also be used for synthesizing or processing material. How? In that works in different technology. Electromagnetic waves will there, so electromagnetic field will be generated, and where we are putting the material or where we are putting the sample, if that electric field will be varied. Suppose somewhere intensity of the electric field will be more, somewhere intensity of the electric field will be less. And when it is electromagnetic means what? Electric field and magnetic field both are there. So suppose we are processing a material, nanomaterial or any micromaterial, suppose we are processing. When we are processing, what will happen? Suppose if we consider this structure also as a microwave oven, there, suppose in this at the middle we are putting the sample, then what will happen here? Since so what will happen here? This PVA is the medium I have said, and in that microwave oven also we have seen, no, in your home, at shop, everywhere we have seen the microwave oven. What happened in the microwave oven? There is, if you noticed it, there is a plate. Above that plate we put the sample. If we put a samosa, then also it there. If we put a material, then also it will be there. And there will be what? There will be some spaces. No, suppose that space is air. Then when we on that switch, that means what? Their electromagnetic wave is generated. And when electromagnetic wave is generated, that gets heated. And we can, what we can do? We can optimize the rate of temperature. Suppose I need at 180 degree, Celsius. Then I will put accordingly. And the time is also one more important. So what it will happen, suppose we have that electromagnetic wave is propagating depending on the sample. Suppose we have the sample which is electric of nature, then definitely how the electromagnetic field's role will be there. It will not be where electric field is maximum, magnetic field may be minimum. That means what? It is processed, and what you have, that electric field is dominating the processing techniques. So this is also a very interesting area of domain of study actually. Just like that, that is known as microwave imaging. The imaging techniques where microwave frequency is used. You know, no? What is the range of the microwave frequency? It will be in gigahertz. So normally from 500 megahertz to higher range, we consider it as in giga or microwave range. So if we consider very high frequency, then it may be your 300 gigahertz, 200 gigahertz, like that. And normally if we say microwave band, then it will be what? It will be up till suppose 20 gigahertz we are speaking. Another important point is what? Another important point is this oven. This oven is also have some dimension. The oven which work at 2.45 gigahertz, the oven which is available at our domestic or at the shop or in your restaurant, it is normally of 2.45 gigahertz. So that's why its design structure is like that. If an oven you want at 30 gigahertz, what will happen? Its size will be different. And when it is 30 gigahertz, the size will be smaller than that 2.45 gigahertz. The dimension at 2.45 gigahertz you are getting. That may be suppose in centimeter or in centimeter range you get. And when we go to higher frequencies, suppose we are going to 30 gigahertz. If we go to the 30 gigahertz, that means then it may be switched to the millimeter range. So that means what? Suppose you want to use the microwave processing technique. If our sample is in centimeter range, just like if we want to bake a cake, if we want to do suppose boil a potato, we can use the 2.45 gigahertz microwave oven. But if I want to process a material or a sample which is having suppose size in millimeter range, suppose you have a material or a sample which is of 0.5 millimeter or suppose 1 millimeter or suppose 5 millimeter, then you cannot process it in that 2.45 gigahertz our available. And this microwave oven which works at, that is known as magnetron. Okay. And there is another one, that one is known as gyrotron, that is very high frequency, that suppose 250 gigahertz someone used to use an this type of system, then that concept is different, that will be gyrotron. So depending on this sample size, it will be, and again shape. Suppose we have a triangular structure, if we have suppose spherical structure, depending on that what will happen, the heating area will also be different. So this, suppose in this way, suppose this is a nanoparticle, this nanoparticle is there. So this is what? This is the effective medium. This whole structure is effective medium. And what will happen? Outside that there will be air and not, and from design perspective, what will happen? Nothing can be infinite. Suppose you are want to make a device. Suppose this is a classroom. Why this is a classroom? This is why this is not a field, because some definitions are there. No, this is a conference hall. Why this is conference hall? Because it satisfied all the components needed is here available. So a classroom, we do not say that a classroom is a conference hall, right? Because if we say from the sound quality also, it satisfied the behavior or properties which are required for a conference hall. So in that way, what will happen? a field is always a field. No, we can suppose a playground. We say that a school playground. Suppose a road. Then also we define no national highway this number. That means it will go from this to this. So everything has a definite area, dimension, definite direction, definite area. So here also this layer is what perfectly matched layer. That means when we target any drug, suppose when we target a drug, it cannot be what? It cannot be infinite. No. Suppose we are using a material and suppose a structure. That structure, if we want to use, then what will happen? It will have some definite dimension and it will not be infinite, and we design in that way, just like a sensor suppose or a CT scan suppose. So it will, what will happen, it will have particular range of no area. Supposing just like we have said label free and label, when we have label, that means what, there is a marker, just like COVID-19 test, there is an antigen test and there is one PCR. So that means there is a difference. No, one is just normally it is detecting, and it takes a small amount of time. And we can say these nanomaterials we can use for point of care application also. So what do you mean by point of care application? Point of care applications means we can use compact size, we can use portable design. Suppose what we normally, what now, suppose at home also we can diagnose that whether a patient is COVID positive or not, or different many those type of kits are available, no, to check different type of diagnostic purposes. So and for some, what we do, we go to the lab to check. Suppose about our, suppose blood, different blood parameters level, we go to the lab. So what happened, some studies are going on where what we do, whether a point of care device can be designed. Point of care device means suppose patient is at home, so at his nearby his bed we can put the machine, and that compact size machine can give you the idea. A lot more work is going on in Northeast also. Many people are working like that. Suppose for biosensing, that memory store I have said. So I was also a part of that. Memory store means memory register. And what I have said, nanomaterials are used, and in all the cases, nanomaterial is the active material. Clear? Active material means what? Everywhere. Suppose here we are here, that's why this is a, suppose we can say a lecture is going on. If no presenter is there, no listeners are there, then definitely it will not be. In the same way, what will happen, those nanomaterials are worked as the active material. Suppose a substrate is there, until and unless we are putting the film of the nanomaterials, it will show the overall behavior, not of that device. But when we are putting that then it will show the different behavior. So in the same way, uh, suppose for targeted delivery, what will happen? We need directive. Directivity, many of you have the idea. Directivity and gain. That is an antenna theory concept. So directive means more directive. Suppose when we are doing the targeted drug delivery, what will happen? It should target the particular cell, no? So that no other healthy tissue get affected. So if suppose catering is like this, then what will happen? It will affect the other healthy tissue also, that is not quite justified and required from the health region. No, if your healthy tissue also, yeah, that's why already for cancer cells already this type of drug delivery techniques are there, but still almost in all the corners of the world people are working that. Why? So that no, not a single point of your healthy tissue get affected. So here suppose if we say here what happened, it is, if you notice this, at this what happened, here no extra loop type thing is there. So it is in a particular direction. So if you notice there is no other loop or no other scattering parameters there. So that means it is directed. So if one can design in that way, then what will happen? Only the affected area will be targeted and healthy tissue will be not affected, or that will not be in touch of that diagnostic purpose. So since time are very limited, I'm just showing you some imaging. So I had said about the XRD. So these are the image of the XRD. So here for different materials we can have different XRD pattern. And it will give you the intensity versus the angle. So these are what? These are the temp, HR temp. Okay. So it will show you that the bar will show you the average size of the nanoparticles. That means in that particular nano material solution or nanoparticle solution, that is suppose we are getting 10 nanometer size, like that. This is what? This is temp. And dielectric property of nano solution. Suppose we have one bottle of nano solution. So that technique will be different from all other techniques. If we want to study the dielectric property of this is different from that liquid. Liquid and solid has different techniques. So these techniques can be just like water if we want to measure. So this technique we can use. Here what will happen? The probe will touch the surface of the water level. So this much for today. This is the basic things and basic concepts. And if one more lecture, if I will get, then elaborately on device point, I will discuss. And if you have anything to just from this basic concept, and I hope today you will go and Google how the microwave oven at 2.4 gigahertz and how the microwave oven at 30 gigahertz, how the size will be there. That is because microwave oven is our daily life instrument. So that also we can use for product design. So how the material we are designing, how that will be worked. And another important point, I will be happy if you will Google is what? That global market, how nanotechnology is governing the global market. And from your own discipline, you will get more this type of thing. And bioimaging is recently focused area of study. So anyone can go in that domain since you are in the last years. Most of you are in the last year of your study. In higher study also, if you go, you'll get that. In MTech, suppose there you must get the option of study computer tomography as a suppose subject, like that. Then you will study all these things. Or suppose material science you can go for. So different things are there. Microwave technology is there. Then suppose RF and photonics is there. So that means your fields will be more compact. This talk is just to ignite your minds that these are also some potential area where I can go for or when I can switch to. Just like the software field also, if you go for any software company, if you learn a software very well, then you can be the engineer for that, no matter from which trade you are. So in that, open for interaction. So if anyone just want to questions, if you want to put. So for online participants also, if you have any queries, please you can ask me. I will give you the option to unmute you, or you can write. মই unmute কৰিছো. কোনোবাই hands raise কৰিছে নেকি? So you have any questions? I am available all the time for you. So during these 7 days, so we can discuss. And from online participants, if there is anything just to interact, please raise your hand. Practical classes will also be there because we already it is there. No, we have processing laboratory, then design laboratory, then computer aided design laboratory is also there. Then testing facilities are also there. So we will, if you will go for those also, you will get the live demonstration of that. Theory classes will also be there on the basic, this type of basic techniques. After lunch break, we have talked from Mr. K. Rajesh, Joint Director from CIPET CSTS Kochi. Okay, sir will talk on recycling techniques. Then in other days, we will have live demonstration also. Just like Thursday, we will have live demonstration of testing facilities. Okay, if there is no question, and from online participants also, no, so I can, my mail ID, everyone know. So if anyone has anything to ask me, you can mail me directly. So now the this session, this technical session is over. Now we have lunch break. After lunch break, we will have talk from Mr. K. A. Rajesh, Joint Director and Head, CIPET CSTS Kochi. You can stay at the same line, or you can rejoin again after the lunch break. The session will start at 2:30 p.m. So you can be at the same line, or you can rejoin the link again. Thank you very much. Good afternoon, everyone. We will start very shortly our next session. Good morning, sir. Good afternoon, sir.
Yeah, good afternoon.
Yes, sir.
Good afternoon. Can you hear me?
Yes, sir. You are audible, sir.
Yeah. And presentation,
Yes, sir.
PowerPoint?
Slide is also visible, sir.
Slide is visible. Yeah.
Yes, sir. So before starting the session, I want to briefly introduce our resource persons are with the participants.
Yes,
So
please.
K.A. Rajesh is the Joint Director and Head of CIPET IPT Kochi. Sir had expertise in the area of polymer for more than 20 years. And today Sir will deliver his expert lecture focusing on recycling techniques. We welcome you, sir. Over to you, sir.
Yes. Thank you. Good afternoon to all the delegates. First of all, I thank you for the nice introduction about me. I thank CIPET Guwahati team, Sri Sanjay Chaudhary sir, and he especially for inviting me for delivering session on plastic recycling technology. As this is a post-lunch session, it is always that some kind of lethargy may be there, but I will try to make my session as interesting as possible. So any questions are there, please type it in the chat box so we can have the question answer session in the end. So the today's topic is plastics recycling technology. So as you all know that CIPET is also actively involved in the skill development, technology support, academics, and research and R&D in the field of plastics technology. We are having different departments like plastic processing, testing, CAD/CAM, etc. So coming to the topic, from morning to evening we use plastics, or whether it is a right from the beginning, from the day starts with the toothbrush, toothpaste tube, the lamy tube, water tank, soap case, home, clothes, kitchen wares, lunch box, etc. And different components are made in plastics. We can see this is a glimpse of articles which we are using day to day in our day to day life. So the plastics are into every sector that is mostly bonded with our life. So the consumption of plastics is 11 kgs in India, and the world consumption is around 30 kgs. And there is a growth rate of around 10 to 15% for this sector. So as you all know that the word plastic, it is originated from the Greek word plastikos, which means that it is capable of shaped and molded. So the plastics under the exertion of the temperature as well as the pressure, we can mold into different shapes. Yeah, I think in the first session the properties might have taken in a taken here. I'll just go through the essence, as these polymers are made up from the units which is called as monomers. Like a chain, the monomers combine to form a polymer. So the two different broader classifications of polymer plastics is thermoplastics and thermosetting plastics. And with the thermoplastics can be repeatedly heated, melted, and converted into product. So around 90% of the plastics components which we use is of thermoplastics. And the advantage of thermoplastic is that it can be recycled easily. So the components which we use can be easily recycled. The commodity plastics are the plastic which it undergoes major recycling process, The major commodity plastics are polyethylene, polypropylene, PVC, polystyrene, modifications like styrene, acrylonitrile, sand, PMMA, etc. Out of that, the largely recycled plastic is polyethylene, then polypropylene, then PVC. So these are all recyclable in nature. The majorly recycled plastic is polyethylene. And after that, the engineering plastics, out of that majorly recycled plastic is polyethylene terephthalate, which we see as in the form of drinking water bottle or the beverages bottles such as Coca-Cola, Pepsi, etc. So all these things are PET, and PET is also undergoing recycling in a very large way. There are engineering plastics like nylon, ABS, polycarbonate. All these are recyclable in nature. The thermosetting plastics, phenol formaldehyde, urea formaldehyde, melamine, polyester, epoxies, etc. They are very difficult to recycle, and generally it undergoes pulverization and go for different filling purposes. Other than that, its recycling is difficult. So when we compare the details of the technical data of plastics versus the other material, we can find that plastics are the very competitive material which can be used in different domestic as well as engineering applications. It is having sufficient strength to meet the requirements of different applications. By comparing with the steel, aluminum and brass, it possesses low tensile strength, but it is having an advantage of molding and also for the recyclability nature. So the advantages I am not telling in detail. You might have already undergone this training in the last session, but the trend of polymers or plastics, it goes from the from the non-structural applications to semi-structural application and to the structural applications. The days to come, the vehicles, especially the electronic vehicles, e-vehicles which we talk now, the hybrid vehicles, everything, the major components will be of the plastics in nature. And also in this now the government has come up with a policy of vehicle scrapping. So now the specific, as per the guidelines of the government, the once it is become the old as per the stipulated period, so once the fitness fails, then it has to definitely go for scrapping process. So most of the old vehicles, it will go for a scrapping, and there is a large scope of recycling, especially for the automobile sector. So the other growth prospects of plastics which we are going for is the conducting polymers and light emitting polymers. So this also is an emerging field where the India is going for different electronic components. Plastic as such in automobiles, it covers different components in hundreds of components in a passenger car. You can see in the form of mirrors, hoods, grills, etc. So when we understand the recycling, when we are going for the recycling, we should understand where the plastics are being consumed sector-wise, which creates the where it's getting consumed and where the resource is available. You can find that the plastics, the major consumption goes into packaging. So the plastic packaging is the major sector. Either it can be food packaging, it can be electronic packaging, it can be the packaging of the machinery, tools, etc. So any kind of packaging, the primary choice is the plastics. So the plastics, then the packaging, this sector, it is the largest waste generating sector, as the purpose is only to protect the thing till it is getting used. So once it is ready to use, either it is a food or machinery, whatever is the plastics, the packaging goes as a waste. So it has to go for recycling. So majorly the packaging sector, the waste is being collected and going for recycling. And then apart from the next sector is the building and construction area sector, where the plastics are being used for different applications like doors, windows, pipes, hoses, etc. Automobile, electronic or electric sector, agriculture sector, etc. So when we see the recycling potential of plastic waste, we can find that around 43%, 44% is polyethylene. The major share of the plastic waste is LDPE or LLDP, low density polyethylene, or linear low density polyethylene, which is being used for applications like carry bags, different wrapping purpose, grocery wrapping, etc. And other sector, other next material is the polyethylene HDP in the form of rigid containers, etc., pipes, etc. So these two together, it forms the major plastic waste, the polyethylene, the sector of polyethylene. Next is polypropylene. Polypropylene is around 16% of the waste coming, and PVC is around 12.1%, and PET is around 10%. So the recycling starts with the segregation of the waste into different plastics. So as far as the recycling industry is concerned, the major focus is for the short life products, like either it is of single use or it is for for products with short lifespan. So which are being used, which are being consumed in a large volume, and the waste accumulation is more. Some of the articles of short lifespans are carry bags film, multi-layers films, woven sacks, bottles, disposable cups, biomedical plastic products, etc. So these are the products of the nature which can be recycled, or which undergoes the recycling in a very faster way. And the plastic, similarly, the plastic products, the other end, we are having long life products like chairs, crates, pipes, etc., which are having around 10 to 20 years of life, and some pipes are also having around 50 years life, which are durable in nature. And these plastic products, they are having good performance, durability, and it undergoes less recycling cycle. So as far as the recycling point of view, the main focus is the short life products. So the source of plastic waste, the types and source of the plastic waste, major plastic waste, the source is municipal solid waste, where the door-to-door collection is done, or collection is done through some common points, where the all the wastes are collected. The plastics, it is a non-degradable waste, is being collected, and it has to be segregated from the source itself. So where it is being collected, from there itself, the plastic has to be segregated using a different bin. And other source of plastic waste is agriculture sector. Then comes the automotive sector, construction sector, the industrial scraps, industrial production waste, virgin scrap is there. The plastic processing industries, where it is a waste or scrap material, product rejection, etc. Then polymer manufacture, hospital and medical waste. So these are the sources of waste, plastic waste, which are the resource to the plastic recycling industries. So the plastic, the consumer waste, how it is going to the recycler is that there will be there are different collectors, either rack pickers, either it can be rack pickers, or there are scrap dealers are available, and in association with the local bodies, panchayats or municipalities, the corporations, they pick up, and then it is going to either to the recycling also directly, or through scrap dealers and wholesalers, it is going to the recycling industry, where it is being sorted out. As I told, the plastics are sorted out according to its um, uh, its classification, and then it is grinded, it's then granulated, and then it is going to the next processing level. So this is the main recycling flow diagram. And out of that, the segregation of the plastic waste is important. Once it is reached to the plastic industry, you can't mix all together, all the plastics together, and go for a product. It needs to be segregated as per its resin identification, and then it has to be produced, manufactured to different other products. So as per the worldwide consumption, worldwide concept, the plastics are classified in from under different number 1 to 7. And the recycling, there you can see that there is a recycling symbol, triangular symbol. It indicates the recycling. It is the material is recyclable in nature, and the number inside it specifies which resin it is, which polymer it is, plastic it is. So 1, it indicates for PET. Generally you can see that the drinking water bottles, the soda bottles, beverage bottles, it is marked as the triangle with inside number 1. So there is a misconception that people they think that 1 means it can be recycled only one time. It is not like that. The 1, it indicates which polymer it is, which plastic it is. Plastic 1 means it is PET, polyethylene terephthalate. The polyethylene terephthalate is the widest, one of the largest recycled product, plastic. And next 2, it indicates that HDP, it is HDP, these rigid containers. It can be tablet containers, or it can be the containers which contains slight acid spore cleaning like Harpic, etc. The containers for the shampoos, etc. are coming in oil bottles, are coming in oil cans, are coming in HDP. So these articles are generally identified with the number 2. So with this, we can sort out this HDPE material, HDPE products. Then 3 is the 4 PVC, polyvinyl chloride. So generally the pipes, fittings, etc. are comes in under this category. Then 4 indicates LDPE, low density polyethylene. Generally the carry bags, the shopping bags, etc. It comes in 4. And 5 number indicates for polypropylene. Polypropylene is generally used for a number of applications, and like different transparent bottles, food containers, the parcel containers, microwave and oven containers, etc. Then medical waste such as syringes, etc. comes with polypropylene. This polypropylene, the medical way generally the advantage of polypropylene is that it can be autoclaved, and so that's why it is widely used for medical applications. And also it comes with a hinge property. So any kind of boxes like lunch box, geometric box, etc., it comes with polypropylene. And the furniture, the major furniture sector, the table, chairs, etc., are made up with polypropylene in nature. So these items are identified with the number which is 5. Next one is polystyrene, the expanded polystyrene, the styrofoam, thermocore. These are indicated with number 6. And all the other products, including the biodegradable plastics, it comes in comes under the number which is called which is 7. It's a polylactic acid, polycarbonate, nylon, the other plastics. These polycarbonate, etc., nylon, acrylics, all these comes in under the 7. Even the MLPs also, that is multi-layer plastics also, are denoted with 7. And this PET, as I told, the PET, the majorly used plastics, you can see that beverages bottles, the oil cans, transparent oil cans, food containers, etc., comes in PET bottles. These are the examples. So these are the resources for the recycling industry. The HDPE, the rigid containers like cans, you can see the oil cans, different cans, and these cleaning liquid cans, etc., tablet containers, etc., are made up with HDPE. And the HDPE is also used for making the crates, and also there are HM cover. HM HDPE is available with a haziness. You can see distinguish LDPE and HDPE with haziness. HMHDPs are haze in nature, and this also undergoes the recycling under HDP. HDP, there are paint containers available. HDP pipes are available with HDP. PVC, generally the profiles, the pipes and fittings are made up with PVC. So these are the products which is coming under PVC. Then medical tubes, vacuum form products, etc. Then LDP, the carry bags and milk pouches are coming under LDP, classified under LDP. The greenhouse films, the films used for making the for construction. Then LLDP, it is water tank, milk container. So these are the, once it is become scrap, so it is segregated like that. The polypropylene, the woven sacks are made up with polypropylene. So these are collected back. Then these disposable cutleries, disposable glasses, the food containers, microwave oven containers, etc., comes under polypropylene. The chairs, furniture sector, and the garments are covered with a polypropylene cover, transparent cover. The polystyrene, they told it is expanded polystyrene, styrofoam products are made up with this multi-layer product plastics. It contains the layers of different plastics, and it is very difficult to recycle in a single shot. So these are the plastics which is coming under the categorized, can be categorized from 1 to 7, and based on that the waste is segregated. This is the first stage where the segregation of the waste is done, and based on this only they will be going for recycling. So main, it should have the segregation facilities. The recycling industry, the main one is the major first facility they should have is the segregation facility, and this is manual sorting. Basically, it's manual sorting with the visual color. It identifies which plastic material it is, and there are, as the technology advances, there are sensor-based separation technology is also available for handling the large volume of the waste, like color recognition system, infrared recognition system, X-ray transmission, X-ray fluorescent technology, Raman microscopy, electromagnetic separator, visual spectrometry, etc. Based on which the it is being sorted out, these segregated automatically. In plastic color sorting, different colors, the color which you need to identify, it is coded. So the digital camera technology is involved in that. So based on the color treated, it identifies and it separates the color. It separates which particular color need to be accepted, it goes in accepts, and other colors it goes in rejects. So this is done by color identification technology. Next comes with the NIR. That is, each particular polymer plastics are having its own molecular spectrum. So based on its molecular structure and its functional group, the spectrum is obtained, and based on the spectrum, it can be analyzed and tell whether it is a polyethylene or polypropylene, polystyrene, etc. So NIR also is used, and based on NIR technology, the plastics are segregated. Then there are X-ray transmission technologies where there is a component of large component of fillers and flame retardants are added, especially for these are used for the electronic waste purposes. So where it is being detected, and based on the filler content available, and it then sorts out. And another alternative technology to FTIR is the Raman spectroscopy, with which these plastics are differentiated. Polypropylene, polystyrene, etc. can be segregated. So once this is the segregation process, which are the first stage of the process, and then it goes for mechanical recycling of plastics. So as I told, the initial one is the inspection. Either it can be manual or with the segregation system. The plastics are segregated, and this segregated plastic goes to the industry and it is getting chopped or washed. So that's the second stage. Next stage is the flotation tank, where the mixed plastics can be again sorted based on the density. So generally the plastics like polyethylene, polypropylene, it's having less density less than 1, and it floats in water, and other plastics it settles down. So these plastics can be separated and then it goes for it can be recycled further. So the flotation tanks also it helps to remove the dust, and then all the dusts are over, and then these flakes are dried, and then it is going for the melting process, and then goes for the filtering, where it is completely removed with the contaminants, and then it goes for the pelletizing process. In pelletizing process, you will get uniform cut size granules, which can be which can be put in for next higher level process. So in a flow diagram, when you see the recovery of plastics, it goes for the sorting, and then it goes for cleaning, and then goes for agglomeration, and then extrusion and pelletizing, and then goes for storage and marketing. So when once the segregation is done, so as you know that the plastics are having high specific strength. So that is its specific gravity is very less, its density is very less. So it is these weights are these articles are bulky in nature. The volume is more and its weight is less. So it need to be compacted so that the volume can be reduced further, so that it can be easily transported to different locations, so that the transportation can be justified. So this is an important technique by which we can improve the efficiency of the articles collected, and it can be efficiently transported. So that technique, this technique is called as baling. So there is a baling is available. So based on the bales, so these bales are compressed together and to make a rectangular blocks, and then it can be transported. So another volume reduction technique is the crushing or shredding. So there are different types of grinders are available. Scrap grinders are available. You can see most of the local bodies, they are equipped with the shredding process. They are having shredders. They are having scrap grinders, which by which they crushes everything and reduces into flakes, and then these flakes are then transmitted to different companies, recycling company. Then the scrap grinder, you should it's a typical scrap grinder machine. It is having, this is a photograph that I can tell, with which volume can be reduced. Plastics are grinded, and then the flakes are formed and small into small flakes, and the volume can be reduced. So there are different cutters are available based on the which product is being used. Based on the volume of the product, it uh, it can be used. And there are pulverizers also available, which is used for products, especially for the rotational molding, like tank and all. So these tanks are all recycled by, first of all, with the pulverizers and PVC based products also. It turns into small powder form. This powder form, and then it goes for next process. In the kind of especially carry bags and all, and during recycling process, it goes through a machinery which is called as agglomerator, where it densifies. It densifies the film, because each and every the film collecting and then drying and then putting into the recycling is not viable. So what it means is that this, once it is segregated, it densifies through heat. So this machinery is called as agglomerator, and this agglomerator, the photograph of agglomerator, I think these are all available in Guwahati CIPET under PWMC, and this and it densifies, the agglomerator densifies, and you get the agglomerator, and then it goes for extrusion process. In the extrusion process, the material is heated and then melted, and it goes through the filter and then goes through the die, and it forms as a strand, the strand form, and then the strands are cooled under the cold water to the bath, and then it is going for pelletizing. So these are the facilities through which the plastic recycling, mechanical recycling is done. I'll just show the video, one video of plastic recycling. I hope the video is visible. So this is a shredding place where the plastics are being sorted out. The shredder or grinder, where it is getting into flake form. So this is the shredding one, shredding operation. The moment I am sharing another video. Is it visible? And this shredded one, it goes to goes for extrusion process. These flakes. This is a hopper through which the plastic is it is feeded, and then it undergoes extrusion process. So this is a simple extruder where it forms the different numbers like blocks. Rectangular blocks are formed, which can be used for further like park benches. So these are the blocks which can be used for making the park benches. The extrusion process, and then let me share another video of PET recycling. The PET bottles are recycled. So shredded plastics are shredded flakes going to recycling facility. They told it undergoes a baling process, and then these bales are shipped. These cut flakes are then going into flotation tank and cooling tank, where this is getting flotation tank. Sorry, in flotation tank is actually the dusts are getting removed. Then after the cleaning of the flakes, and then it undergoes the drying process. This is the dried flakes. Then it is heated and homogenized. This is a drying process. The flakes are dried, and these dried flakes are then now ready for extrusion. This is the extruder where the flakes are fed, and there is a screw inside it which positively conveys the material from feed zone to melting zone to die zone, where the through the die, these filaments are coming out. Till here, all the in mechanical recycling of the other plastics, we get instant form, as I as shown in the last video, no previous video, previous photograph. that it comes in a strand form, whereas here it comes in filament form. So basics of the recycling is same, but in PET we get in filament form. And this filament then it is turning into yarns. These yarns are then going in weaving, and then it forms the clothes. So there are long fibers and short fibers are available. Since the long fibers go for garment application, and short fiber goes for pillow filling applications. This is the PET fibers. It is basically a polyester. So what we get is the polyester fibers out of PET bottles. So this cloth is then cut into different shapes and making in for t-shirts and jerseys. The Indian last World Cup, the Indian team, cricket team, they won they made the jerseys which is made from recycled PET. So the PET bottle, from the PET bottle, it forms into the jerseys. So these kind of these industries are available in India. So this is the extrusion process that you can see that. So in the case of PET bottles, what we got is the filaments, and then it turns into cloths. But in the case of other recycling, general recycling, polyethylene, polypropylene, the principle is the same. Where here we get the strands, and these strands are then chopped and then pelletized. So it requires facilities of recycling industry. They require the storage facilities and also the three-phase connection and water supply. So these are the mandatory requirements they should have. They should have the extruder for the same. Then this is the pelletizing machine where it turns into small granules. So the PET bottles generally it turns into fibers. So the plastic bottle, it is baled, and then from the bottle again we can get either bottle also or the different strands also. And the short fibers, as we told, there are short fibers are also formed during the process, recycling process. as for during recycling process, the short fibers, and then it is used for making the carpets, upholstery fabrics, interlining, protective clothes, etc. Then the PET bottle. Then once it is the PET is extruded into sheet, then PET is then again thermoformed, and it can be used for making the transparent boxes for the egg casing or foods, etc. So this is one of the emerging product. It comes in supermarkets where they cut vegetables. Now it is everything is ready to cook. Chop the vegetables, is fruits, cut fruits, um, eggs, everything it comes in PET thermoformed box. And PET is also used for making the bowls, and apart from the PET, the rigid plastics like HDPE, polypropylene, etc. After the recycling, it goes for manufacturing of the products like luggages, suitcases, the stools, small stools, chairs, etc., crates, etc. It can be made, and this is a group of particles. It can be produced with plastic, recycled plastics. Polypropylene also used and used for manufacturing of supli, twines. That's twines. It is made up with. This is also like cottage industries. They take polypropylene and they manufacture the strands and make it as supplies. And other than that, the polyethylene or polypropylene are manufactured for making the domestic articles like uh, buckets, mugs, flower pots, um, dustbins, etc. So the woven sacks are then turned into products. Generally, it is actually collected. The waste is woven sacks. Once it is collected, then it undergoes the cleaning and drying process. It is shred, and then after granulation, it goes for making the pots. You can say very cheap pots are available. These pots can be made of HDP or PP woven sacks. Then multi-layer film also is compressed, and then it is used for making the different park benches, etc. The film can be used for making the raincoats or box strapping, plastic footwear, etc. Cheap plastic footwear can be made up with the collected polyethylene articles. Box strapping is also a recycled, generally a recycled plastic product. Is made from basically polypropylene. So when we say the availability of the materials, the polyethylene is the material which is widely available and is going for material recycling in India. And then polypropylene, then PET, then polystyrene is expanded polystyrene, and this data will vary because of the ban or for the single-use plastics. So the plastic waste management, the other options are, other than the mechanical recycling, what are the other options? Like mixed waste recycling is available. There are the plastic waste also is used for road construction purpose. It is also used for making the petroleum products like furnace oil, diesel, etc. It is also used for making the energy recovery in cement kilns. So there is a waste plastic can be turned into oil. So as you all know that plastics are basically made from crude oil, the petroleum. So it can be distilled under a high temperature in that atmosphere, and then it can be made into furnace oil, diesel, etc. The plastics also find as a it's having good fuel, good energy, and it is also used as a fuel in cement kiln for co-processing. So it is used basically the waste which cannot be recycled. So generally, as I told, the waste which can be recycled, it can be segregated and recycled. Some of the plastic waste like MLP, multi-layer plastic, it contains different plastic constituents, and it is very difficult to undergo mechanical recycling. So the products which cannot be recycled with the mechanical recycling, it undergoes. It can be used in for co-processing in cement kilns for energy recovery. It is having a high energy value when comparing with the municipal solid waste, other solid waste, and wood. So it is a source of energy for cement processing. And other alternatives such as these bags. This you can see there are chips, lays, and all. So these chips, everything, it can be combined together to form the bags, good decorative bags. So there are some NGOs which undergo, which are involved in that. They employ the people, and then these MLPs are collected, and then it is given, and then it's beautifully stitched the gum and together to form different decorative bags out of it. Then another sector is the wood plastic composite, where the basically the plastics which are PVC and all this nature, the furniture which is with the furniture, then it is then recycled and wood particles are added. The wood particles are added. Wood particles are available, which is generally burned in nature. So this can be added with plastics to reinforce the plastics. It improves the mechanical strength and modulus, and then it can be used for making the planks. For the in extruder, it needs to be added plastics as well as the wood need to be added, and then it can be turned into plastic composite. And wood plastic composite, it is used for different durable applications like planks. It's also used for making the, you can see the different article furniture like tabletops, stool chair, there's pathway blocks, etc. are made up with these plastic composite. Plastic composite. So this park benches, as I already clearly told, that plastics with wood can be made into it, and it can be used. It can be some good substitute for the wood in different furniture applications. Ergonomic doors, poly pallets, etc. High durable pallets, etc. are made up with can be made up with the wood plastic composite. You can see the beautiful planks and beautiful furniture. It can be made up with wood plastic composites. So this also can be custom made. Either it can be the amusement park, or this is another application of the PET bottle, where the PET bottle are then filled with sand, and then it is used as a construction material. This is used as a construction material, and then it is plastered to give. This is one of the building which is made up with only with the PET bottles and sand, and then it is nicely decorated in tourist places. It can be done. And then the plastics, these bottles are clubbed together and to form Christmas tree. So this is another use of bottles. Apart from the recycling, it can be upcycled for making different articles out of it. So the plastic waste recycling, it generally employs the clean. It gives the clean environment, employment opportunities. It gives the economical products. It gives the substitute for the different wooden materials, and there are business opportunities also. And in this time, I just want to mention that India is having highest recycling percentage throughout the world. India is actually recycling around 60% of its plastic waste, whereas the other countries is very less. Hence, there are different employment opportunities and business opportunities in plastics recycling area. This is some of the products. It is made up with plastics, plastic-based plastics and wood composite, etc. So, with this, I just conclude my thing, and I will want to share some more videos for the upcycling. The plastic waste, it is used for making the park benches. You can see with the latest technology.
Sir, video sound is not. Sir, sound of the video is not coming.
The plastics are shredded and then it goes for 3D printing application. Additive manufacturing.
So voice is not coming.
Of the got the video, so it's very good, amazing custom made products can be made up with plastic waste. I want to play one more video.
Sir, am I audible to you, sir?
Yeah. Just a minute. I would like to share one more video.
Sir, am I audible to you, sir?
Yeah.
Yes, sir.
Just a minute. I would like to just tell one more application.
Yes, sir.
So this is the major applications of mixed waste plastic, which can be employed. Is widely adopted and it is employed. I missed this slide actually in between. That is the construction of plastic coated bitumen road. So the even you need not go for a different kind of complex operations into it. The simple process is that plastic waste, collect the plastic waste, and then just go for a drying process, and then it can be shredded into it, uniform shredded piece. Then this shredded piece, and then it is put over the conveyor. Over the conveyor where the road for the road construction. This is used for road construction purpose, where the metal aggregates are heated generally around 155 to 165 degree. So during that temperature, the when the metals are getting heated, or that you can spread the flakes of the plastics so that the stone aggregates are coated with the plastic base. So it forms these stone aggregates. It forms a uniform thin layer of the plastics, and it is adhered into it. So this aggregated, this coated aggregate then undergoes a tarring process, and so it will be having an excellent adhesion between the stone and to the tar, so that the binding strength is very good, and these mixed plastics can be utilized for it. It is estimated that around 1 ton of material is required for laying of 1 kg of road. Hence, there is a tremendous potential for this technology for using the plastic coated bitumen road. So this is also widely accepted throughout India. It is NHA is following, and all there is a code for road construction code for NHA, and also for constructing the rural roads laying with the polymer, that is plastic waste. In around 10% of the polymer plastic can be mixed. 10% of the waste plastic can be mixed with the bitumen, and in terms of durability, it enhances the durability, and also you all know that plastic is waterproof. It is resistant to water, so we will get a waterproof road, and it avoids the potholes, and it extends the life of the road. This is one of the beautiful applications of the plastic waste in the construction of the bitumen. With this, I thank you all for listening my presentation. Now the forum is open for question and answer. Thank you once again. I thank CIPET-GUWAHATI for providing me the opportunity for presenting. Thank you.
Thank you very much, sir. Thank you very much for this this lecture focusing on the waste management, then how waste management can generate entrepreneurship, and all the techniques related to the recycling processes. We are very much thankful to you, sir. And now the session is open for interaction. Participants will interact with you, sir.
Yeah.
Yes, sir. You can come here and take the question. G. Kirubakaran has a question. We had sent him a request to unmute.
Hello, sir. Good afternoon, sir.
Good afternoon.
Sir, compared to PLA, nylon is a recyclable one, sir. Compared to PLA.
Sir, actually, this nylon is generally used for automotive applications.
Okay,
and
okay.
it is used for bumpers, etc. And it has got good recyclability. It is recycled also for making the different threads and all. It can be recycled into it. Whereas PLA undergoes the organic recycling, like biodegradation. So its purpose is different. It can go for mechanical recycling. But nylon undergoes the more mechanical recycling than PLA. PLA also is recyclable, but it goes generally undergoes with the organic recycling.
Sir, regarding emissions, sir, compared to PLA and ABS and nylon, which is producing maximum emissions? PLA, ABS, nylon.
Emissions as such, sir, that exactly we need to study the full life cycle analysis, then only it can be told. Okay. And as far as these three plastics are concerned, each one are used for different applications. Nylon is generally used for high strength, high modulus applications, like automotive applications. ABS is used for making the different impact resistant applications, like any part, electronic part, the outer covering is generally ABS in nature. Either it can be a TV, it can be a printer, it can be a laptop, etc. The ABS finds application. It has got an excellent impact strength. So it is used for these kind of applications, and all the three materials are recyclable in nature. And PLA is generally used for for replacing the single-use plastic articles, generally disposable plastics and disposable applications, carry bags, etc.
The difference between amorphous semi-crystalline polymer and the crystalline polymer, sir. Amorphous polymer. 3 polymers are there.
Yeah. In generally, the crystalline polymers, it has got a very sharp melting point. You can see that nylon 6 melts at 220 degree. It has got a very high, very sharp melting point. Whereas the amorphous polymers, it has got a wide range of melting point. Means it starts melting at one particular temperature, and then it finishes the melting point at another particular temperature. So that is the main difference. And semi-crystalline is somewhere, the properties are somewhere in between based on its percentage of the crystallinity. So semi-crystalline materials, it has got a it is having it is also having melting point, but it is not an exact temperature. It may be the temperature in the range, say 120 to 7. Suppose LLD, linear low density polyethylene. It's a semi-crystalline plastic. So it is having a temperature, melting temperature of around 122 to 125 degree. Whereas nylon is having a sharp melting point, and it's due to its crystallinity in nature. And amorphous plastics mostly are transparent in nature. Either it is a polystyrene, very transparent in nature. That's the difference between crystalline.
Sir, sorry, sir. One more question, sir. One more doubt, sir.
Yeah.
Recycling properties, sir. Compared to PLA, ABS, recycling properties available in nylon, sir.
Yeah.
Nylon is a recyclable one.
Nylon is a recyclable one, and it is recycled, and it is recycled into, as I told you, different threads. It is made up with nylon. Nylon filaments are made up with recycled nylon. Nylon can be recycled, and it is also recycled, and part of the recycled material, it is used for manufacturing of cost-effective different products. Especially the plastic, instead of using 100% virgin, 100% pure material, around say 20%, 30% based on the cost, it is added for getting the optimum properties and reducing the cost of the product. And mechanical applications is also used for here. We have done is also used for making the stay wire for the electrical application. Any more questions? Any other?
Thank you, sir. Thank you, sir.
Thank you very much.
Thank you, sir. There is another question from side.
Yeah.
Sir.
Yeah.
So my question was that, like you mentioned that we use only 10% polymers in road construction, sir, with the bitumen, sir.
Yeah,
So
yeah.
why is it that we are using only 10% and why can't we use recycled polymers at a higher percentage? That would have been much better.
Because that much only it is required for coating of the stone. The purpose of the using the plastic is to give a layer over the aggregate to have a good bonding with the bitumen.
So is it possible that we use more percentage of it in
More
a cool
percentage
region,
means
sir?
the mixing will be very difficult. As I told you, the way is when we tell about the weight percentage, the percentage is very less, but it is having huge volume. It's a flake material. No, when we are handling it is a flake. It is in the form of a flake material. Flakes, small flakes. It is a very lightweight. So when you are taking even 1 kg means it's having huge volume. Volume is there. Volume is more. So as your percentage increases, the mixing will become very difficult, and the binding
Okay.
strength will again come down. Yes, and that's the optimum one. And these are all approved by the Road Congress, and there are codes are also available. The construction codes are available. Yes,
Thank you, sir.
yes.
Thank you, sir. Sir,
Thank
I
you very
have
much.
one question, sir.
Yeah,
Still, I want to know, sir,
Yeah.
how recycling can be mm, took to entrepreneurship, means how recycling, knowledge of recycling can lead us to be an entrepreneur, sir.
Yeah, it's a good question, and these facilities are already available there. That's what in between I mentioned also. It is giving a good scope of entrepreneurship. Large because waste is available in plenty. So only thing is that you need to segregate and get a good clean waste, which is not contaminated. Should not be contaminated from dirt or food, etc. When we get a clean waste, it can be a clean waste of plastic. It can undergo the recycling process product. And in CIPET, the facilities are available for making plastic waste. PWMC center also is available in CIPET-GUWAHATI, and any other CIPET centers also they support for making the products with plastics recycling.
Yes, sir. PWMC is there, sir.
Yes.
Plastic waste
Yeah.
management. And sir, this waste management will make the places clean also.
Yeah, definitely. Thank you very much.
Thank you, sir.
Yeah. So, all your permission, I make a leave. Thank you very much.
Yes, sir. Thank you very much, sir. Thank you very much for spending your valuable time by sharing this informative session, sir. Thank you so much, sir.
Thank you.
So, dear participants, this is the last technical session for today, and we will again resume tomorrow at 10 a.m. And 10 a.m. There is a lecture by Praveen Basov, who is a joint director and head from CIPET CSTS Ranchi. So tomorrow we will have a live demonstration session also. So please join at 10 a.m. in the morning. Thank you so much. And the link will be same. Those who are online participants, for their information, the joining link will be, WebEx link will be same one. So please join using the same link by tomorrow morning 10 a.m. Thank you so much. So thank you, participants. Tomorrow again we will meet at 10 a.m. in the morning.